The diagram shows a particle P of mass 4 kilograms held in equilibrium by two light inextensible strings AP and BP. The string AP makes an angle alpha with the horizontal and is attached to the ceiling at a point A. The string BP is horizontal and is attached to the wall at the point B. The tension in the string BP is 30 newtons. Find the angle alpha and the tension in the string AP. Give your answers correct to 2 decimal places. So here's the question then in summary form. We've got it all mentioned here in the diagram as well. So we need to find alpha, and we've got this arrangement. Well, 4 kilogram mass, we'll have the weight acting downwards, won't we? So let's draw that in. There's the weight, and that will be 4G as a force acting downwards. There'll be this tension in here. We're told that tension is 30 newtons in this string here. And there'll be this force here acting at P from the tension in the string. We'll label that T. So it's in equilibrium, so we can resolve our forces, can't we? So the best thing to do then, well, let's resolve it horizontally. Here, what have we got then? We've got T cos alpha minus 30 equals 0. So that tells us that T cosine alpha is equal to 30. And also, if we resolve vertically now then, we've got T cos of this angle, which will be the sine of this angle. So T sine alpha then, minus the weight 4G, again equals 0. So that tells us then that T sine alpha is equal to 4G, wasn't it? Move the 4G over, we get 4G, this is 2. So divide one by the other, so let's do 2 divided by 1 gives, and the t's will cancel, and we'll simply be left with sine over cos, which is tan alpha. And that's equal to 4G, this value, over the 30. So let's tap that in the calculator then to find alpha. So it'll be shift tan of 4G, 4 times the 9.8, divided by 30 equals 52 to 2 dp, 52.57 degrees. 52.57 degrees. And that's the 2 decimal places. There's the angle alpha. Now the tension then. So also the tension is equal to, move this sine alpha, 4G over sine alpha is equal to. Okay, so we got this value here of degrees in as alpha in the ants, haven't we? So if we just do 4 times G, 4 times 9.8 divided by the sine of the angle alpha equals 49.36 newtons. And there's the tension in the string.